So it's cosecant of negative t. All right, so back up then. Okay, cosecant of negative t. Well, then that should be the same as sine of negative t, but it's reciprocal, right? So sine of negative t is negative 1/2. Cosecant of negative t should just be the reciprocal of that. So it should be negative 2 right here. Okay, what about 45? 45 said what? Cosine of negative t is negative 1/5. Now that's not a special value that we know, right? That's not one we memorize. That's not one that's on our unit circle. So we wouldn't know what t is here. And what were you supposed to find on this one? Cosine of t and secant of negative t. Well, secant of negative t is probably the easiest one. Those go together. They're reciprocals, right? So if cosine of negative t is negative 1/5, then this should be just the reciprocal, negative 5. Okay, but what about here? Well, we said yesterday that cosine and secant are even functions. That means opposites in, you get the same output. They're equal. Okay, like x squared. You put in a 2 and a negative 2, you both get out 4. Same output. So what should we get right here? It should be negative 1/5. It's not opposite. It is the same because opposites in, opposites out. But now, let's think about this. Now, this is where it starts to get a little weird because we talk about negative t, but is it possible that negative t is positive or it's vice versa, right? But if we think of the unit circle, let's try to draw a picture that would be negative t and negative theta. Well, but yet have the cosine be negative. Now, this is something we're going to get more into in a later section. But what quadrants is the cosine negative? 2 and 3, right? Because cosine is the x. So in 2 and 3, cosine will have a negative value. So I would need to draw my negative t somewhere in either the second or the third quadrant. Okay, now this is where it's going to get weird. So negative t, we would normally go negative direction, and if I want it to be in the third quadrant, I have to go all the way around to there. Are you with me? Okay? I mean, this would be, to me, a harder way of doing this. The better way is just knowing that these are even functions. If they're even functions, opposites in, same thing out. So cosine negative t, cosine t are going to give you the same out. That, to me, is the easy way to do it. But we could still reason our way this way. So if we go negative t and put it into the second or third quadrant, let's put it into the third, what would be positive t? And so that's giving us an x value here of negative 1/5. Doesn't that make sense? That could be negative 1/5 right there, right? That would be an x of negative 1/5. What would be positive t then? That would go over, if this much is negative t, wouldn't positive t have to go that much? Are you with me? Right? Negative goes this way, positive goes that way. So if negative t is going to land over in the third, positive t would have to land over here. Now, what would be that x coordinate of this point? Wouldn't it be the same as the x coordinate of this point? Right? Does it make sense? So that would be another way to reason your way through it using stuff we've already learned. Okay? Little trickier maybe to think of, but it would validate what we just figured out there. Okay. Now, the reason I kind of wanted to go through that, you're like, well, why go through that kind of harder way? Number one, it reinforces stuff we've already done. But number two, it might help us on 47, because to me, I'm kind of curious. Nobody seemed that interested in doing 47, but maybe you were just being shy. Luckily, we got Jack to ask questions for us all. Okay, we got A is sine of pi minus t, and then the other one, we're supposed to do sine of t plus pi. Now, somebody want to tell me their rationale of how they thought this through. Anybody? Jack? No?
I'm trying, I got it this morning. I'm trying to figure out how I got it.
We don't know what t is, so we don't know what quadrant it is, but we could narrow it down to 2 quadrants. What quadrant would t have to be in here? T is our theta, t is our angle. If you know the sine of t is 4/5, what quadrants it got to be in? Sine is the y. Y is positive in 1 and 2. So it's got to be in 1 or 2. Correct? All right. So it's got to be in 1 or 2. So I guess what I'm trying to do is get you to think of how I was doing it earlier. Okay? Now there's something we're going to learn here in a little bit that would help us on this one maybe, but even then I don't know if it's that easy. So if t is in 1 or 2, let's put it in 1. Let's put t in 1, because it actually is not going to matter. Let's put t right there. Where is pi minus t going to be? Down here? Isn't it going to be over here? It's going to be over here. Pi minus t, well, let's do degrees here. Let's say pi is 180, because that's easier to think. So let's say pi is 180, right? So, and let's say t is 30, just to make it easy here. So what's pi minus t? Be 180 minus 30, which is 150. So I think Noah's got it. Wouldn't it be over here? Wouldn't pi minus t have to be right here? Where that would be t right there. So wouldn't this be pi minus t all the way around to there? Right? It would be t short of pi. Right? So it'd be right there. Well, what's the sign of that one? I didn't really draw those equal. What's the y value of those 2 points? Doesn't it have to be the same? It's got to be the same. So in quadrant 1, we said it was 4/5. So what's this one got to be? It's got to be 4/5. 4/5. Now, actually, going back to geometry, it's a supplement. It's right. If x is an angle, 180 minus x is its supplement. That's what that would be, right? And so it would be the one that adds up to 180. So this plus 180. So this plus that. Pi minus t plus d makes 180. Okay, but it would be in that quadrant. So that's how you can reason your way through it. Okay. All right. Now, some of you might be thinking, well, yeah, but you said originally it could be in quadrants 1 or 2. So what if we would have drawn t over here in 2? What if that would be t? What if t was 120? What's 180 minus 120? Oh, so that would have put the other one back into here. So wouldn't we still have the same thing? Right? The y coordinates would still be the same. So it's going to be 4/5. Okay, now let's talk about t plus pi. Okay, so again, we know sine it's either in the first or second quadrant. Let's put it in the first, make it easy. Okay, so there's t. Where's t plus pi going to be? Which quadrant? Well, if I put it in 1, though, it's going to be in which one? It's got to be in 3, isn't it? Because this is going to be 180 plus that angle. So if this is 30, we're going to be down here at 210. We're going to be 180 plus that. Okay, so that's like half the way around. So we're going to go from here, so the red, so t plus pi plus t is going to be down here. But isn't it going to be just part of the same line? Is it just going to be extended? I mean, go back to some old geometry. Aren't those 2 angles going to be the same right there? Kind of the old vertical angles, remember that? Okay, so if this one has a y value of 4/5, if we were doing a circle, right, what would that y value be? Wouldn't that have to be negative 4/5? Right there. See what I mean? That's our reasoning. Now, that's just the beginning of this. It's not like you have to be able to be great at that right now. We're going to continue this as we move on. Some of what I was just asking you there about quadrants, like what quadrant is sine, if sine's positive, that's 1 and 2, that's really good because we're not going to really need to know that in depth for a couple of sections yet. When we get to those sections, we're a long ways there already, right? We're already thinking about this really well, okay? A lot of you, so that's good, okay? So these are little ones I kind of added in that are a little harder than maybe the normal. All right, so let's go ahead. Oh, shoot, I was going to talk about the calculator one. So, like, Addie and I were just talking about What was that one? It said cosine of negative 1.7. Was that the one? Okay, so if you have your calculator, so go ahead and get your calculator out, and it tells you to do the cosine of negative 1.7. Now let's do that in degree mode, and let's do it in radian mode. So go ahead and do cosine negative 1.7 in degree mode, and then do it in radian mode. And just jot them down. Well, you should already have the radian mode, because to be honest, radian was the right answer. Okay? Okay, what are you getting in degree mode? 0.999 something, right? What are you getting in radian mode?
Negative 0.12.
So 129. Two very different answers, right? Two very different answers. Now, which one's the right one? Radian, because there's no degree symbol on this. But what's really important to me is that you understand why those two answers are what they are. Okay? That'd be a great kind of bonus, or a trickier question on a quiz is, Susie typed into her calculator cosine of negative 1.7 in degree mode and got 0.999. Why? Typed in radian mode and got negative 1.29. Why? Well, again, let's go back to the unit circle. Think about this. Where would negative 1.7 degrees be? Barely a teeny tiny little angle in quadrant 4, right? Negative 1.7 degrees. Now, cosine is the x coordinate of that point, if we put our circle in there, assuming we put our unit circle. Well, what is the x of that going to be? Well, what is it if it's right on 0 here? What's the x coordinate? 1. Well, so isn't that going to be just a little less than 1? So it doesn't make perfect sense that we got 0.999, because the calculator thought we were putting in an angle of 1.7 degrees negative. And so it thought we had this teeny tiny angle. Put in a positive 1.7 in your calculator. Put cosine of positive 1.7. Same thing. In degrees, in degree mode, same thing, 0.999. Now, that just shows two things we've just been talking about. 1.7 would be just right up here in quadrant 1. Wouldn't that have the same x? Sure. And we also just talked about how cosine's an even function. Even function, you put opposites in, you get equal things out. So cosine negative 1.7, cosine positive 1.7 should be the same thing. Okay, what about this radian one? Where is negative 1.7 radians? What quadrant is negative 1.7 radians? Now, before you answer, think about it. And if you need a little help, think of the string. Think of the string. How long was your string? 1 what? 1 radian. So what quadrant is negative 1.7 radians? Quadrant, it's negative. So 3. Wouldn't one string take you to about there? And another string took you over somewhere in here, right? Now, what would be the x coordinate of that point? Pretty small, right? Pretty small. And negative. So negative 0.129 seems reasonable. Seems reasonable. Okay? All right. So I think it's important that we understand why the calculator is giving us those two things. Because on the one hand, we were putting in 1.7 degrees, which would be here. On the other hand, it thought we were putting in 1.7 radians, which would be here. Very different things. 1.7 degrees and 1.7 radians. Very different things. Okay? All right. Get your notes out. All right. We're going to shift gears. When we introduced trig, we said there were two ways of talking about the trig functions. One was referencing the unit circle. Okay? Now, when we did the unit circle, we made a big emphasis on radian measure. right? And learning the idea of radian measure, because that's such a big part of the unit circle and why it's important. We're going to shift gears to what you learned back in geometry, right triangle trick. We're going to start talking about, so now we're going to be using degrees a lot. Now we'll still have some radians, we'll throw radians in there a lot, but when you're doing real life kind of geometry kind of problems, then angles is a good use. That's where, degrees, that's where degrees is common, and that's where degrees is useful. Okay? So, essentially, in a right triangle in the blue, we want to think of opposite, adjacent, and the hypotenuse, of course, is always across from the 90. In the red, I'm suggesting that you just memorize these two triangle relationships. Now, I went ahead and wrote them so that the hypotenuse was 1. That way it corresponds with what we did with the unit circle, because in the unit circle, the radius is 1. So I think we should memorize those values. Now, I think it'll be easier because we're memorizing the unit circle, so those values should be very familiar. So really the only thing, so 45-45 triangle is pretty easy, and a 30-60. And we just got to remember the 30 is the small angle, so the small leg is across from it, and 1/2 is the small leg, because 1/2 is 0.5, and root 3 over 2 is 0.866. Okay? And so root 3 over 2 is going to have to be across from the 60. So there is no such thing as a standard position when we're doing a triangle, right? We're not doing an XY axis here or anything. We just got this triangle. We won't have any angles bigger than 180 degrees, right? And so forth when we're talking about just triangles. All right. So we want to memorize the sides of those triangles. Now, when we put this all together, that's going to help us even in the unit circle. And I'm going to show you in a minute, we can think of the unit circle with triangles. Right? So it's not just about memorizing the coordinates on the unit circle. We can draw in triangles as well, and that can help our understanding. And sometimes I have students in calc, when they look at the unit circle, they put in triangles and they think of SOHCAHTOA. And that's fine. That's fine. But I think we want to memorize these sides. Again, the 1/2 is always across from the 30. The square root of 3 over 2 is across from the 60. And 1 is always on the hypotenuse. Okay? All right. So, I just wrote these down again. We had them yesterday. I don't know if you need to write it down. The bottom stuff maybe, but you probably already know SOHCAHTOA, so I don't know how important that is. These are just the reciprocal things. Now what we did, when I wrote them the other day, I wrote sine was y over 1, and so we said cosecant would be 1 over y. Okay, that's in the unit circle. Here, this is just saying that sine is a reciprocal cosecant. Cosecant is a reciprocal sine. That's all that's saying. So it's the same thing. It's the same thing. So and I wrote that with cosine and secant and tangent and cotangent. Okay? So that's all that is. Understanding those identities. And then, of course, our SOHCAHTOA sine. Now, notice how I did that in blue. So what I wanted to do is, you got to understand which one's opposite, which one's adjacent, which in reference to which angle. So if I'm talking about theta, which is in blue here, then this bottom leg is the adjacent leg. And the one across is the opposite. But if I'm talking about alpha, that's the Greek letter alpha, lowercase, I think, lowercase alpha. If I'm talking about the Greek letter alpha, then the bottom one's the opposite leg. And then the up and down one's the adjacent leg. And of course, the hypotenuse is always the hypotenuse across the 90. So we just got to make sure what angle are we referring to. Now, you know, when we're talking about the unit circle and we're in standard position, we're always talking about this angle down here, right? When we put it on an XY axis in standard position. But in a real life triangle kind of problem, who knows which angle we're referencing, right? So just some kind of subtle differences, but they all connect back together at the end of the day, whether we're talking about triangles or we're talking about the unit circle. Okay? All right. So here's just, and again, I don't know if you need to write this down. I just wanted to show you on the unit circle how we can think about triangles. So if I've got a 30-degree angle, I can think about this as a right triangle here. And I can think, okay, here's my 60, which we usually don't even care about in the unit circle. This angle up here, so we don't even think about it. But across from 30 is 1/2. Across from the 60 is root 3 over 2. Here's a 1. So clearly, this coordinate is going to be, the x will be root 3 over 2, and the y will be 1/2, right? So if you're struggling with memorizing the unit circle and the thing with the fingers doesn't work for you, then you can always throw in a 30-60 kind of triangle. Now that works in the first quadrant. That gets a little trickier when we go over to the other quadrant, right? And so next section we'll talk about that. Okay, how we can put triangles into the second quadrant, third quadrant, fourth quadrant. But at least in the first quadrant, see, so the same thing here. Here's a 45. Put in a triangle. Root 2 over 2, root 2 over 2, 1 on the hypotenuse. So there's your coordinate. Same thing. X, Y. Okay, and then a 60. Okay? All right, so that's kind of a connection between what we've been doing, unit circle and triangles. All right, so trig identities, so I already had these up here. So these are just some things, but then, so you don't need to write those down again. Those are just the reciprocal identities, but these we might want to write down. Okay, so tangent is equal to sine over cosine, which is our y over x, okay? But y is a sine and cosine's the x, so it's sine over cosine. And then cotangent's a reciprocal. So cotangent's cosine over sine. So sometimes that's a good way to think about these. Tangent is sine over cosine, and cotangent is cosine over sine. Okay? Now, okay, if I put this triangle into this circle, Pythagorean theorem would tell me that x squared plus y squared would equal 1, right? Now, x is the cosine and y is the sine, so therefore by substitution, wouldn't it be true that sine squared plus cosine squared equals 1? X squared plus y squared equals 1, so it would be true that sine squared plus cosine squared equals 1. Now I got those backwards. I got y squared plus x squared, doesn't matter. Sine squared plus cosine squared equals 1. That's a fundamental identity that we will use as we go throughout the year. Sine squared theta plus cosine squared theta equals 1. Okay? Now, what we can do with that, and you don't need to know why or where this comes from, but if we take, what I tell my calc kids is you don't have to memorize these two over here, but you can create them very easily. Because what if we took this side and divided everything by sine squared? Divide this side by sine squared and divide this side by sine squared. What do you got? You got 1 plus, what's cosine squared over sine squared? Well, what's cosine over sine? Cotangent, look up there in the top right. Cotangent. And then you square it. That'd be cotangent squared. Okay? And then what's 1 over sine squared? Well, what's 1 over sine? 1 over sine squared would be the same as 1 over sine all squared, right? What's 1 over sine? Cosecant. So this would be cosecant squared. So you see how you get the bottom one here, right? Now, what if instead of dividing by sine squared, I divided everything by cosine squared? If I divide everything by cosine squared, what would we get? We get sine squared over cosine squared, which would be tangent squared, plus cosine squared over cosine squared, which is 1, equals 1 over cosine squared, which is secant squared. So these two just come from this one right here. Not going to have to memorize those yet. This one for sure, I tell the calculus, I mean those two for sure. You memorize those two, and that's easy. And then cotangent's easy, gets a reciprocal. And these two you can get by just dividing if you need them. Okay, but we won't be messing with those right now. But I want you to get those down and have them. All right, so those are some relationships between these functions. Okay, let's go through some examples here. So I'm going to do this one, then I'm going to have you try, maybe we'll just try number 6. We don't have time for too many. Okay, so here's some examples of what's going to be on your work tonight, okay, on your homework. Okay, so here's a triangle. All right, we're shifting now from unit circle to triangle. All right, here's a right triangle, and there's theta. What is sine theta equal to? And what they're going to do is they're going to give you a triangle, they're going to say, write the 6 trig function. So what's sine theta? 5 over 9. So Cato. Opposite over hypotenuse. 5 over 9. That's it. That's it. Should get an answer between -1 and 1. Well, actually, we're not going to get negatives because we're doing real life kind of triangle things. Everything's going to be positive. It's kind of like doing everything in the first quadrant right now. Which is nice. What's cosine? Whoops, we need the adjacent. How do we get that? How do we get that? Pythagorean theorem. 9 squared equals 5 squared plus adjacent squared. So adjacent squared is equal to, what's 9 squared minus 5 squared? Get your calculator out real quick. How much? 81 minus 25 is 56. So let's just go square root of 56. I don't even need to simplify it. I don't even care. Okay? Square root of 56. I suppose with that wouldn't even simplify down, I don't think. Would it? 4, yeah, it'd be a decimal. I'm trying to think, is that a perfect square of anything? I don't think so. 4? Yeah, it would be 2. 4 times 14, I think. Be 2 square root of 14. But I don't even care. Square root of 56 is fine. Square root of 56 is fine. Okay? I don't care about that part. That's algebra. I care about the trig right now. So what's cosine? Square root of 56 over 9, right? Adjacent over hypotenuse. What's tangent? So cotolan. Opposite over adjacent. 5 over square root of 56. I can't decide if I'm okay with that. I'm okay with that. Am I good? I'm good with that. Okay? I'm good with that. On this one. Now, not with square root of 3 over 3 and those things. We need to write those. Okay? There will come a time where I may say simplify that or whatever. Okay? But for right now, I'm good with that. Okay? What's secant? Secant's the reciprocal of cosine. So once we got cosine, we can just go 9 over root 56. Right? I can go back to the triangle, but I don't think I want to memorize those. I think I'm just going to do SOHCAHTOA and then do the reciprocals. So cosecant's a reciprocal of 9 over 5. Cotangent, reciprocal of tangent. Square root of 56 over 5. Okay? I'm not even going to have you try that one. You got it. We got it, right? Yeah. It's like basketball practice. We got it. We talked about it. We did one quick example. We got it. Right? All right. So next one. Next one. Okay? This should be really quick. Okay? But now you're supposed to memorize that triangle. So put the legs on that. Put the legs and hypotenuse on that triangle. It's still in your notes if you haven't memorized it, right? So, here's what I got. You see a 45, right away, root 2 over 2, root 2 over 2. It's an isosceles triangle. The two 45 legs have to be equal. They're both root 2 over 2. And the hypotenuse is going to be 1. We always want the hypotenuse to be 1 on our 30, 60, 45, 45s. We memorize it that way. It makes things easy. Now, I can talk about the cosecant one down here, but sine would be, no, so we got to pick one. So let's pick that one. So sine would be opposite over hypotenuse. But now, you might be saying, but wait a minute, I already memorized these in the unit circle. I already know sine of 45 is square root of 2 over 2. I don't need a triangle. Great. That's fine. Don't do it. Right? But if you haven't, you got this, right? We'll all come together. It'll all be the same, and we'll all know it. It'll be great. Sine of 45. So if you remember these triangles, we can just look at it. We can say opposite over hypotenuse. Opposite over hypotenuse. That's it. Cosine. Adjacent over hypotenuse. Root 2 over 2. Tangent of 45 is opposite over adjacent. This over this is going to be 1. Okay, now, this one you might not have been as good on. Now, I said I was okay with this earlier. Cosecant be the reciprocal sine, so it'd be 2 over root 2. But remember where that came from. The reason this is root 2 over 2 is it was 1 over root 2, and then we simplified it. We called it root 2 over 2. So really, this one I'd rather you have be just as root 2. Okay, now that seems kind of weird. Would make up your mind. Well, right now, if you have 2 over root 2, we'll call it good. Okay, that's fine. Okay, but when we need to, you should remember how to rationalize the denominator anyway. Okay, so I won't get too worked up about that. Cotangent, of course, reciprocal that. All right, try this, 30 and 60. Got a triangle, it's got a 30 in it, it's got a 60 in it. Put your fractions on there that we're thinking about. It's in your notes if you can't remember right away. Again, as you're thinking about those, 30 is pi 6, 60 is pi thirds. You know, we got some of that, the sine and cosine at least, on our unit circle, right? The sine and cosine are there on our unit circle. Maybe you're thinking about that. Maybe not. You want to think about a triangle, you think of SOHCAHTOA, right? At the end of the day, it doesn't really matter how you think about it. if I give you a quiz where I do like we did today and give you a unit circle and just hand it to you and tell you to put those coordinates on there, you could draw in triangles, right? You could get all those first quadrant ones by drawing in triangles. If you just memorize those two triangles, right? You don't even need the hand thing or any of that other stuff. You could draw in triangles. If you memorize 30, 60, 45 triangle, you'd have it. And then once you have the first quadrant, this is not surprising, but and maybe some of you saw what I'm about to show you. Maybe not. We've had a lot of things going on, a lot of things to try to remember. The unit circle, radians, a lot of new stuff here. But one of the things that you notice when you put them into a triangle, you start looking, you say, well, wait a minute. The sine of 30 is opposite over hypotenuse. That's the same as the cosine of 60, right? Because what was the opposite for 30 is the adjacent leg for 60, right? And the same thing would be true with, say, tangent, where tangent of 30 is opposite over adjacent, and when you move to the 60, it's opposite over adjacent, it's flipped, right? So you start looking at this, well, excuse me, I'm sorry. So tangent, if we go tangent is this over this, cotangent is the reciprocal of that, and so cotangent would be the cotangent of 60. If we look here, the cotangent of 60 is the same as the tangent of 30. Let me say that again. The tangent of 30 is the same as the cotangent of 60. Likewise, the tangent of 60 is the same as the cotangent of 30. Tangent of 30 is the same as the cotangent of 60. Okay, look at sine. The sine of 30 is the same as the cosine of 60. The sine of 60 is the same as the cosine of 30. So maybe we start getting a little sense of the names of these functions. Now, it seemed a little confusing with the reciprocal. You had sine was paired with cosecant, which seemed kind of weird that those two, with their names, don't have anything kind of in common. But now I think maybe we do see something a little bit with the names. Last one here. Secant of 30 is the same as cosecant of 60. And the cosecant of 30 is the same as the secant of 60. This brings to mind, now what were those pairs? What were paired in that scenario? Sine was paired with cosine, secant was paired with cosecant, and tangent was paired with cotangent. Now, tangent, cotangent were paired together when we did the reciprocal thing also. But so that brings to mind something, and this is in your book, page 3, I don't know, something. This idea of co-functions. Co-functions. So go ahead and write that down if you would. But this idea of co-functions. And 90 minus theta, if you go back to your geometry, 90 minus theta would be complements. Remember complementary angles, angles that add up to 90? Complementary angles are angles that add up to 90. So what the co-functions are, the name comes from complementary. Okay, so the sine of 90 minus theta is equal to the cosine of theta. And just to put in red here, above that, that would be like saying the sine of 70 is equal to the cosine of 20, right? The sine of 70 is equal to the cosine of 20. 20 and 70 are complementary angles. And that would always be true because of the relationship in a right triangle. You got your 90-degree angle. The other two are going to be complementary. They're going to add up to 90. And so these are co-functions. So that's kind of where the name comes from. We have the sine relationship and then the cosine relationship of that. So you got sine and cosine, you got tangent, cotangent, you got secant, cosecant. That relationship, that the prefix co in there comes from complementary. Okay. Now, to be honest, we don't use that a whole lot. As you go through calculus and stuff, and maybe even more into this class, you'll use those reciprocal relationships more often. So in that relationship, it's sine with cosecant, and it's cosine with secant, and so forth, right? And we often think of the trig functions as the big three, sine, cosine, and tangent, right? And then we think of the other ones, cosecant, secant, and cotangent. And that's because of the reciprocal relationships, right, is why we kind of have the big three. On your calculator, what buttons do you have, right? You got sine, you've got cosine, you've got tangent. You don't have the reciprocal one. So anyway, so the cofunction's not a huge deal, but it kind of related to what we saw earlier with those problems on number 47 that we did in the homework. Okay, so let's go through a couple of scenarios that are like your homework, and then I'll hopefully give you a little bit of time to work. So in your homework, you're going to have kind of a table like this, okay, and it's going to be kind of like so, and you're supposed to draw a triangle, okay, and there's columns or there's blanks, I think, that you have to fill in. You're supposed to fill in the blanks, kind of thing. So let's go through this. If you want to jot it down, fine. You're going to do some of the odd ones that are like these. Okay? So let's say we got cosine of 45 degrees. So what would be the radian of 45 degrees? What would be the radian that's equivalent to 45 degrees? Pi fourths, right? So hopefully these are going to be fairly easy ones. Look on your unit circle if you need to. But the focus here is not the unit circle. The focus here is the triangle relationship, okay? What is the function value? What's cosine of 45? What's cosine of pi fourths? Off the top of your head, you got it? Root 2 over 2. Okay, now it's good if you got that. If you don't know it, maybe you do the triangle first. If that hasn't quite been committed to memory, how about you do a 45-45 triangle? That's what they want. Actually, the directions say draw a triangle that represents this relationship. Well, the triangle would be root 2 over 2, root 2 over 2, and 1, right? And the cosine of that would be adjacent over hypotenuse would be root 2 over 2. So what order you fill these in, I don't care. Draw the triangle first and then get this, that would be great. Okay, so next one, we got pi thirds. Well, what's the degree equivalent of pi thirds? 60 degrees. Now we want the function value of that. Not quite there on the top of your head, maybe. It is 1/2, but maybe that's not right there yet. Okay, so that's okay. Come over here, let's draw yourself a triangle. Let's make that a 60 right there. And what goes across from the 60? Root 3 over 2. What goes here across from the 30? 1/2, and of course 1 always on the hypotenuse, right? And what is the tangent of, oh, I'm sorry, I got that wrong. It's not 1/2. What was I thinking of? What trig function with 60 is 1/2? I was still back on 22. Cosine? Is that cosine of 60 is 1/2? Cosine of pi thirds is 1/2. Okay, back on the unit circle, I was thinking cosine still, but this is tangent, so the answer is not 1/2. But that's okay, we got our triangle. What is it? Tangent is opposite over adjacent. Root 3 over 2 over 1/2. The 2's are going to cancel. What do we get? Just going to be root 3 over 1, or just root 3. But again, it would be an opposite over adjacent, right? Invert and multiply, the 2's cancel, however you want to think about it, and you get root 3. So that's what would fill in the blank. That's what function value means, right? That's that output of the function. Okay, cosecant, we don't care about that right now. Well, I guess we will here, because square root of 2. Okay, we don't know the angle. They didn't tell us the angle. Well, I'm going to draw a triangle anyway, and I'm going to go, well, which one does it have to be if it's got a root 2 in it? Doesn't it have to be a 45-45? Right? Assuming it's going to be one of our special angles, or 45 or 30 or 60. 30-60 doesn't have a root 2 in it. It's got to be a 45. Okay, it's got to be a 45. So if that's root 2 over 2 and root 2 over 2 and 1, cosecant is the reciprocal of which one? Sine. Okay, so sine would be, sine of this would be opposite over hypotenuse. It would be root 2 over 2, right? Well, the cosecant of that would be flipped. That'd be 2 over root 2. Well, if you simplify that, right, you get 2 root 2 over square root of 2 times square root of 2 is 2. Those would cancel. Sure enough, you get root 2. Okay, so root 2 is the reciprocal. Remember where root 2 over 2 came from? It came from 1 over root 2. That's where root 2 over 2 came from. It came from 1 over root 2. So the cosecant is that flipped. So it makes sense that's a 45-degree angle, and of course that's pi fourths. And there's a triangle that would represent it. Okay, so you got to unpack that a little bit and think about that. So you're going to have some homework problems there where we want to think of those as triangles. Okay, moving on here. What I'm doing is giving you some problems similar to your homework here. Okay, giving you some problems similar to your homework. Okay, cosine is equal to root 2 over 2. I think, excuse me, on this problem, you were supposed to find theta in degrees and radians without your calculator. So, what does theta have to be right here? 45 degrees, pi over 4, right? Dead giveaway, root 2 over 2. This is easy. Tangent, now this one's not quite as easy, even if you're thinking of the unit circle, but when is a tangent 1? Isn't that opposite over adjacent? If it's going to be 1, that means the opposite and adjacent have to be the same. What triangle does that have? 45 degrees or pi 4. So we're supposed to give it in both. Okay, let's move on to another one. 60. Tangent of theta is root 3. What kind of a triangle is going to give me root 3 if I do opposite over adjacent? Well, if the root 3 is going to be on top, that must mean I must have had to have, that's going to be a 60, isn't it? If I use this as my angle, if I go opposite over adjacent, I end up with root 3 on top. That must have been the root 3 over 2. We only got 2 choices. These are either going to be 45, 45, or 30, 60, right? They're going to be one of those two. Okay? Well, that looks like a 60 degree or a pi thirds, right? Where's cosine 1/2? Wasn't that the same one? Right? And maybe on this one they're supposed to be. You can do either one. I think they're supposed to match up. It's going to be 60. Cosine would be adjacent over hypotenuse. Adjacent over hypotenuse, which would be 1/2 over 1. So that is 60 and 30. Okay, couple of story problems. Let's turn to page 68, or excuse me, page 308. You don't have to in your book. If your book's not out, not a big deal. But it said, let me just read it to you because I want to get through it quickly so we can give you some work time here. A 6-foot person walks from the base of a tower, a broadcasting tower, directly toward the tip of the shadow cast by the tower. So we've got this big tower, and there's this shadow. And so here's the sunlight. The sunlight's coming through, and it's casting a shadow down like so. Make sense? Okay, the shadow that's cast by the tower. So here's our sun up here. We got a 6-foot person that's walking. And of course, this tower is kind of see-through metal, right? And so the sun's going to be casting a shadow on the person as well. When the person is 132 feet from the tower and 3 feet from the tip of this shadow, which is right here, his shadow just starts to appear beyond the shadow of the tower. So in other words, when he gets right to here, okay, and he's 6 foot tall, then when he gets to here is when his shadow will also be at the same place as the tip of the shadow. Does that make sense? Okay, and at that point it said he was 3 feet. This isn't exactly the scale. 3 feet, okay, he was 3 feet from the tip of the tower shadow is when his shadow began to overtake the shadow of the tower. Does that make sense? So he's got to be right in this line, and so there's his shadow tip is at the same place as the tower, and he's 6 foot tall. What we don't know is how tall the tower is. These are the kind of problems we use, and you probably even remember doing some of this in geometry, these kinds of things, because what kind of situation do we have here? You recognize similar triangles? You got a big triangle here, and you got a small triangle here, right? Similar triangles, the sides are in proportion, the same ratio to one another. Now, what the problem says is draw a right triangle that gives a representation. We did it. Use a variable to indicate the height of the tower, which we did. X. Use a trig function to write an equation involving that unknown quantity. So let's call this theta. So if we want a trig function, we need an angle in there. What trig function would involve the x and also involve values that we know? Sine, tangent, or cosine? Would it have to be tangent? Because we don't know anything about the hypotenuse. So that rules out sine and cosine, right? We got the opposite, which is x, and we got our adjacent down here. Opposite and adjacent, that means tangent. So we would write tangent theta equals x over 135, because the whole side here is 135. Okay, but that would also equal, tangent theta would also equal what? 6 over 3, right? Then the last part says, part C says, what is the height of the tower? Well, since we know these, we wouldn't have had to write the trig equation. Later, we will find out how to find what theta is here and so forth with our calculators. And I think you did it in geometry, but we won't worry about it right now. You would just have to solve this. And remember cross multiplying? You would just take this times this and divide by this, right? So 135 divided by, or 135 times 6 divided by 3. What do you get? 270. So the tower would be 270 feet tall. They have to be in proportion. Okay, that's a thing with similar triangles. But that's the idea. Now, we're not going to get in most of the problems, any of the problems that are on your homework, they're going to tell you what that angle is, so you can type that into your calculator. So if this was 27 degrees, you could type in tangent 27. If we were just doing the red part of this, if we just had that and you knew this was 27 degrees, you could just take tangent 27 degrees on your calculator, multiply by 135, and then you would have it, right? So that's the kind of stuff you would have on your homework. Okay, so let's go on those right there, and you can get a little bit of a start. Hey, make sure to stop the recording, Mr. Clark. Oh, thanks, guys.